All right, let's get into it. We're about to uncover a brilliantly simple idea that literally keeps the internet from grinding to a halt. It's this fundamental organizational trick that stops massive networks, think huge universities or big companies, from just collapsing into total chaos. So let's start with the problem. Picture a big organization's network as it gets bigger and bigger. More computers, more phones, more devices, they get added every single day. And pretty soon the whole thing gets bogged down. It's slow, right? Because every single device is shouting on the same party line. It becomes a security mess and just an absolute nightmare to manage. So what do you do? Well, to get to the solution, first we have to understand the address system. See, every device on a network has an IP address, and honestly, it works almost exactly like a physical mailing address. It's made of two key parts. The first part is the network ID, which is like the city and state. It gets a piece of data to the right general area. And then there's the second part, the host ID. In our little analogy, this is the street and house number. It pinpoints the exact specific device inside that larger network. So the network ID gets the data packet to the right city, and the host ID gets it to the right house. Simple, right? But here's the kicker. This basic two-part system is precisely what causes that giant traffic jam in our university example. This is where the clever trick comes in. You don't need to build a brand new, separate network for every single department. No way. The real solution is to take your one giant network city and just divide it into smaller, more manageable zones. Let's call them digital neighborhoods. And these digital neighborhoods, well, they have a technical name, subnets. Subnetting is the formal process of creating these smaller, more efficient subnetworks. It's the key to bringing order to the chaos by creating these contained little communities inside the larger network. But this brings up a pretty obvious question, right? If our IP address only has space for a city and a street, where does the information for this new neighborhood level even come from? I mean, how do you redraw the digital map to add this crucial extra layer? The magic happens by borrowing a few bits from the host ID. It's so clever. You take a small piece of the address that was originally just for identifying a specific device, and you repurpose it. That borrowed piece, that becomes the subnet ID, the neighborhood identifier. So your address structure transforms from two parts into three: network, subnet, and host. So how does all this work? The tool that makes it all possible is the subnet mask. Think of it as a special blueprint, or maybe like a decoder ring for the network's routers. When a router sees an IP address, it lays the subnet mask over it, and that instantly tells it which part is the network, which part is the subnet, and which part is the final device. It's the key that lets them read this new, more detailed address. Now check this out. This is what's so powerful about this whole borrowing technique. Because we're using binary bits, the growth is exponential. If you borrow just 2 bits from the host part of the address, you can create 4 distinct subnets. Borrow 4 bits, you get 16 subnets. Borrow 6, and boom, you have 64. This gives network admins incredible flexibility to design their internal layout. Of course, typing out long numbers like 255.255.240.0 all day would be a pain. So network professionals use this handy shortcut called CIDR notation. It's just a slash after the IP address, followed by the number of bits in the network and subnet parts combined. It's clean, it's simple, and it's way faster. And here is the absolute crucial point. This entire elaborate system of digital neighborhoods, it's a purely internal secret. The rest of the internet has no idea it's even happening. Yep, as far as any computer on the global internet is concerned, it's just sending a packet of data to a single large destination. Like our 137.207.0.0 example, it delivers the mail to the main post office for the entire city, and that's it. Its job is done. It doesn't know, and it doesn't need to know about all the little neighborhoods inside. But the moment that packet arrives, the organization's internal routers spring into action. They act just like local post offices. Using that subnet mask as their guide, they read the neighborhood part of the address and deliver the packet to the right subnet, whether that's the engineering department, the student dorms, or the library. And this right here shows you the main benefit perfectly. Without subnets, every single conversation from every device creates one massive digital traffic jam. But with subnets, traffic stays local. A file sent between 2 computers in the engineering department stays inside the engineering subnet.
It never has to clog up the main network pathways, which means way less congestion and faster speeds for everybody.
So, what are the big takeaways from all this? Subnetting gives you three huge advantages. First, like we just saw, improved performance. Second, way better security. You can build firewalls between your subnets, so if a virus infects one neighborhood, you can contain it there instead of it spreading to the whole company. And third, it just makes managing everything so much easier, letting you organize the network in a logical way that actually mirrors the real world. And it all comes down to this simple, elegant formula, 2 to the power of s, where s is just the number of bits you decide to borrow for your subnets. This little equation gives network designers the power to create as many unique, isolated neighborhoods as they need to keep things running perfectly. Ultimately, subnetting is just a beautiful piece of network engineering. It transforms a single, flat, chaotic network into a structured, hierarchical system that's efficient, secure, and can scale up to incredible sizes. And it does it all by simply redrawing the lines on the digital map. This is just one of many elegant, invisible solutions that make our modern internet actually work. It's a real testament to clever problem solving, and it just leaves you wondering, what other hidden architectures and ingenious tricks are out there, quietly keeping our entire digital world from falling apart?